6.
So that would be 05, right? If you round it or you leave it?
Leave that in your calculator.
Okay.
Okay. Right, and so that's gonna give us what,
38.6495.
6,495. Okay.
And she was right on the other thing of the 39.61.
That was the customer.
Yeah, I just wanted to let her.
Okay,
She was right.
and the interpretation, please. Everybody gets silent.
That one's 90%?
Yes.
The one that
I
was
am
laughing, she talked.
90% sure that the true population is between
That means she know what she doing.
38.6495 and 39.35.
Good, the true population mean is between those two numbers. And so we got a smaller confidence interval, a tighter estimate because we took a bigger sample. Any questions there? All right, do you want to spend a few minutes working on 24?
Yeah.
All right,
We
yeah?
didn't get to it.
Okay, how are you feeling? Are you good on this?
Yes.
Do we want to like skip 24?
No, we do 24.
Do 24? All right, let's do 24.
Punta Cana? No. Puerto Plata? Nice, fun. I've never been, so. Take lots of.
Thank you. Page 2, this is the one, 24. Okay.
And now let's see. Okay, so now first. Oh, and what's the second one? So that was the one is this and
If you look at the formula.
oh, yes. And
Hey,
First, let's find out this.
no, we're bringing out
It's good.
Yeah, I just don't know how to set decimals. I need to go online and see, find the dimensions to change that. Because my answer doesn't come up with 4 places, only 2.
So now this is the part.
What are we gonna find?
Yeah, you're looking for the 95%. Okay, so what I'd like to do is draw a picture each time. So if you're gonna be 95% confident, what percentage time are you gonna go?
that's our standard.
5% wrong. Alright, but how's that 5 gonna break down? It's gonna be half the upper tail, half the lower, all of the lower tails.
Yeah, yeah.
It's gonna be split.
We got the 1.96.
Split.
Yeah, the
100%
1.96.
of the time you're gonna be too high, 2.5% of the time you're gonna be too low.
Same. Yeah, it's a very even number, 95% is very good.
Calculation.
So if there's 2.5% in that upper tail, what is it below that? Now draw that picture. Draw it with the tail, we can see the. Draw it like this one. 2.5%. So you see that's the area under the curve. 2.5%. So shade in that 2.5%.
I have I have
You're shading it.
97.5.
This is the line shaded. See how it's shaded? There you go, okay.
Yeah,
So that's
it's
2.5%
1.96.
of the area. Under that square, under that curve total is
It is.
100%. Is everything, all the
Oh,
data.
so it must be the same as the other one?
Every person in the town,
I'm sorry.
every go over there, whatever. So 2.5% is up here, how much is below that?
So they're not the same as the other one.
Perfect.
So you see what's the
Yes, yes, yes. So you're gonna look in the middle for 0.97.
Oh, I see.
Two point
Bingo.
two.
Bingo. Got it. Alright. Good job, John. Good job, John.
My problem,
That's a good calculation.
yeah, problem I'm having is that it's writing my stuff for me, so I need to change it, I'm trying to figure out how to change it.
Alright, once you figure it out, tell Mom.
She has the same thing?
To come up with 3.47.
So root of 4.
Because at the end it's just zero. so-
Yeah, yeah.
But I got 0.35.
No, that's weird.
I mean, I don't know if I have wrong, but it's really, you don't get the same number. 22. Is it 22?
So you saying
2.2.
Oh, okay, yeah, that's right.
that's what I got, we spent a lot of numbers on this.
I got this,
It's a yeah,
25,
you don't mislead.
Oh, that's what
That's
this
all you got.
Yeah, I don't know what store number.
Charm, 1.9.
Right, no, I know, but I'm just wanna make sure it's a 3, 4, and we round it from here, make it 80.
You don't round that, you store it. See your store in your calculator. That's the thing, if you have to write out by hand,
That's what I'm doing.
that's.
That's what I'm doing. If I had written
This
that,
here's this.
yeah,
Doesn't work.
Are you always?
I don't know how to use that.
1.19. 1.97
Yeah.
equals. The margin of error is 0.1, right? Or equals 0.9
I know.
over n.
That's still.
This is the margin of error.
No, wait, you put confidence in it? Yeah, of course. You don't want 50, go to 4, go to 4 decimal places.
This is the margin of error.
Oh, 4? So from the 1
I think like that.
That's your
Go
margin of
to
error.
4 just to be safe.
So that's your margin of error, that goes to the side equals this times that.
See, it's tricky.
What's tricky?
Just don't.
Oh, yeah. So what's the margin of error for C?
Yeah.
That's the key to that question. I remember what margin of error is.
There's a lot of numbers that's in there, I was playing all over the place.
It's the Z, it's the amount you add and subtract from the point estimate, sample mean. So if the confidence interval goes from 7 to 7.2, and the middle point is 7.1, sample mean is 7.1, how much are you adding and subtracting from each of those? Alright, should we do this one?
Let's do it.
Alright, so in this case, we wanna know the average advertising budget of a furniture store. Maybe we have a lot of furniture stores, maybe we sell advertising to furniture stores. So we take a sample of 40 furniture stores. We find the average advertising budget in our sample mean is 7.1. We happen to know the population standard deviation 2.2. So we're going to take that 7.1 plus or minus our margin of error. And our margin of error is going to be some number of standard errors. Let's figure out our standard error first. Standard error is the population standard deviation divided by the square root of sample size. What does that come out to?
0.347851. 34781.
Alright. So that is our standard error.
Yes.
Question, before you move any further.
Yeah.
That was it was 0.34785. Do you round it to 9 or you leave it, okay, I just wanna make sure, you're good.
Yeah, if that was your final answer, you would round it, but you're not gonna round it, you're gonna leave it in your calculator.
That's what I was
Cause
asking.
I've been writing out the whole,
Yeah, so
That's what I was asking.
My calculator don't-
Something off.
doesn't let me do it in 2 steps, so I was writing.
You use the cell phone?
Yeah.
Yeah, use spend $20 on a different calculator. Or you can buy the, who's got the
This one?
HP? Yeah, that's a good one. And Tina's got this one also. This is a highly reputable finance calculator. The Texas Instrument BA2 Plus.
Yeah, it's the same one as this.
Fairly user friendly. You will have lots of uses for this in finance. And what does it cost?
$20 on Amazon?
Less than 30. Wow.
Tax deductible then.
It's a tax write-off.
What payment do you use that?
Alright, so, if we wanna be 95% confident, how many standard errors are we gonna need to go plus or minus?
1.96.
1.96? Good, is everyone comfortable with that?
But for the 95,
Alright, 1.96 times 0.3479, what does that come out to?
0.68?
1.6817. 1 cent.
Alright, okay, 0.6819 is our margin of error, so we're gonna take 7.1 plus 0.6819, 7.1 minus 0.6819, what do we get for the lower bound?
6.1.
7 point, 6 point.
6.418.
8, yeah.
Okay, and what do we get for the upper bound?
7.78.
Okay, alright, and what is the interpretation of those two numbers? Go for it, Jay.
We are 95% confident that the population means falls between 6.418 and 7.78.
Fantastic. What was the next part of this question? Oh, if we change the sample size, right? So if we have, instead of a sample size of 40, what if we have a sample size of 100? 100. Alright, so this changes. Now we need to take the square root of 100. And this is gonna change. All of this is gonna change. Yes, Lee?
with the Z score of the 95, and the 1.96.
Yes.
It's not even in this chart. How did they get the 1.96?
Alright, so if you wanna be 95% confident, that means you're gonna get it wrong 5% of the time, right? 2.5% of the time, you're gonna get it too high, 2.5% of the time, you're gonna get it too low. So you need the z value that separates the upper 2.5 from the bottom what?
2.5.
Now, what's below 2.5%?
Oh, below 2. Right.
All of this,
Right,
everything, what's below 2.5%?
90.
7.5.
Yeah, so the whole thing is
So that
100.
goes to 10, right?
Now,
And
this
you gotta
whole,
do 5. If you split in 5, that make it 100 already. 95 point, and then the 2.5 and the 2.5, it rounds up to 100.
alright, so there's 2.5% here, 2.5% here, and there's 95 in the middle, it just
Right.
turns out.
Right.
So what's below this part here?
97.5.
97.5.
Because
Would
95
it
plus
be-
2.5 is
Add in the 2,
97.5.
so it's 97, because the 2.
97.5 is correct,
Right,
yeah.
okay.
But it's easiest just to remember that there's 100% under this
Right.
whole curve. So if there's 2.5% up here, 100 minus 2.5, 97.5. The cool thing about the z table is it tells you the area below
Right.
that particular z value.
I like to be clear on.
So what you're gonna do is you're gonna look in the center of that chart for 0.975. And what do you, yeah, put your finger on 0.975 when you find it.
Right here, yeah. Oh, it says 9 point, okay, let's see. Okay, got it.
Yeah, wait.
Right here.
Yeah, so you got your finger on it? Okay,
Yes.
so tell me the z value associated with that area under the curve.
Yes. 1.96.
Yes.
Yeah, I got it. I see it.
Perfect, beautiful.
Thank you.
Alright, so we're gonna add 1.96 standard errors. And what does our standard error come out to if our sample size changes to 100?
22.
22?
Yeah, because it's only zeros at the
Now,
No.
point
22.
22. Alright, very good. So 1.96 times 0.22. Excellent. Okay, so what does this come out to? New term for tonight, margin of error.
0.1312.
Okay, excellent. And when we take when we take 7.1 minus our margin of error, what do we get? Okay. And what do we get for the upper bound? 3.1. Okay. Interpretation.
We are 95% confident that our population mean will fall between 6.668 and 7.52.
Very good. Outstanding.
I
Um,
think it sounds good.
Did you want to do C? Some people, if you worked on it, we can do it. Okay, so this says we're 95% confident, and we have a confidence interval from 7.0 to 7.2. What was the sample size used in this study? So we're looking for sample size. Alright, this is the same, this is the same. If we're 95% confident, this is going to be our z value. So this is gonna change, I think. Yes. This is what we're looking for. Duh. Alright, all we know is we have a confidence interval from 7.0 to 7.2. Alright, so if we had to interpret that, we would say I'm 95% confident that the true population mean is between those two numbers. What is our margin of error in this case?
0.1.
Alright, so margin of error is the amount we're going to add and subtract from 7.1. So this is going to be 7.1 plus or minus 0.1. So if we take 7.1 plus 0.1, we get 7.2. 7.1 minus 0.1, we get 7.0. So this part here, this margin of error is 0.1. Put this down here. This is 0.1. So what goes into that? Let's keep working backwards. We know we've got 1.96. We know that much. And times our standard error. We don't know our standard error yet. So let's write this equation out over here. Let's do it that way. Let's say 0.1 equals 1.96 times this. This is our standard error, divided by the square root of n. Okay, so times this, we're looking for standard error here. So let's put what we know about our standard error right here. 2.2 divided by the square root of the unknown n. So now we have an equation with one unknown. And we just do some cross-multiplying algebra and we figure it out. Alright, everyone's good there? I won't make you do cross-multiplying algebra too much like this that I can recall. Don't think you have a question like this on the exam. But if you do,
You would know.
alright. Okay. If anyone wants to work this out, we can work it out during the break or after class or whatever, but you have an algebra, fine, I'll do it. Okay, so first thing we do, let's get rid of this 1.96, divide both sides by 1.96, divide by 1.96.
So we did last
So 0.01 divided by 1.96 equals what?
Point zero
You
five
did the same thing.
0.57?
You know that.
something.
Oh.
I just saved it in my calculator.
0.0510.
Okay, equals, and you know this cancels, right?
Right, because it's,
Equals 2.2 divided by the square root of n. Alright, let's multiply both sides by the square root of n to get this in a manageable form. So multiply everything by square root of n. So on this side we've got square root of n times 0.051 equals, and this the square root of n cancels on this side. Right? So this cancels here, equals 2.2. So now we take 2.2, we're going to divide both sides by 0.051. Divide this by 0.051. Alright, this cancels on this side. And we've got n, square root of n, equals 2.2 divided by 0.051. What does that come out to? 43.13. It's like that?
Well, it would be one.
No, 4.3. Okay.
You like 4.2?
4.3. 2.2 divided by 0.0. Never mind.
she got 43.13.
Alright, so we now need to square both sides. So let's square the square root of n, and let's square this. So square root of n squared gives us the actual value for n. 43.13 squared gives us,
Let me see how this square. Oh, one, yeah, exactly. 1,860.822.
so that is our sample size.
Yes, yes. So now we can do everything else. That's perfect.
You must round to a whole person.
Ooh.
Alright, good work, let's take a break. Come back at 8:10 and we'll finish this up?
Yeah, no, I saw it.
Did you see that?
Yeah.
Did you take the last thing?
Yeah,
You did.
because you have to see what, it's in the wording of those things, you know, you'll see it at the end, it's, you know.
You cannot be normal and ask that.
Not so bad.
No, but it's the definition of what that is.
I selected the four. I don't
She's not doing it, so.
When I was submitting, the thing is reasonable. So I can say the answer.
Monica, you have this one?
Yeah.
Monica, you have the calculator? That's the same, I have the rounding calculator, that's the same one you have?
Yeah,
I'm trying
with
to
the,
figure
it has, yeah, the two spaces.
Yeah, I'm trying to, I found a way, but. I'm trying to get.
Oh, okay.
You were trying to do them.
Right, and I didn't.
So should it have 5 decimal spaces?
At least two.
Hey, David, how are you?
Okay, so I think I figured it out.
Everything's gone.
That's what it is.
It would contain.
Which one are you copying?
Yeah, I'm going to the back, you know.
Three.
Sorry, man.
You got the you got the homework question
Oh, which one?
for
How you guys
tomorrow.
handling?
I didn't look at it.
I get
You
confused.
look at it? I ain't look at it yet either.
I've been doing all this, I'm gonna do it tonight or
I
tomorrow.
didn't even do the quiz or the homework for this.
But you can pull the 80.
I'm gonna do it though. Yeah, I'm gonna do it. I just didn't get around to it. But I'm gonna do it though. I know. It's a lot.
You know, actually, so got that to that.
So I didn't look at tomorrow's homework because I've been doing all
Oh,
this.
yeah. So whenever we look at.
But I think it's just an email though. I think we said look at the
Sometimes he does.
like you gotta like you sending an email.
No,
That's not the homework?
You notice that?
chapter 5, exercise 5:13.
Right, it is to look at like the aim to look at the keywords or some shit,
Yeah.
buzzwords.
Yeah, buzzwords, but it's not an email you send.
But it's supposed to be like
But it's soon.
what, hold on, let me see.
I don't know, you're supposed to upload it on Word, whatever,
Yeah,
I gotta.
right, focus. Yeah. But my numbers be off too. It seems like their numbers be different from my numbers. Like I be having 6s, they be having 8s.
Yeah, exactly.
Yeah, I can't do that. I'll be.
I can. I have a lot of time right now. I have a lot of time right now.
I put the whole question, yes. And nothing. Only one.
That's why he said.
Only one.
So basically the answer is the average will always be within giving. Or within the center.
Right?
You know, the interest just keeps racking up, and I'll just be more and more debt. No, I've come to terms that I will be starting with engineers. And I don't want everybody at 10 years is a nonprofit, but we'll see if that happens. If not, it's either I die and it's, because if you're not with a nonprofit, they give you loan forgiveness. So it's either I'm in 10 years in nonprofit and I get loan forgiveness, or I die and I get loan forgiveness. What do I do? Oh, yeah.
Sorry to bring you about what I did there right.
Because
Today was like, yours is your
bring no work, but I just bring the next.
As a school master, and came over here without only pay.
Yeah.
And a lot of
No, they
countries,
usually
like
they
education.
pay.
Even
First I was starting to pick an answer, I was like, no, I gotta read this carefully.
Parfait. No, I wanted to tell him that you was right. You know? No, I know, but he agreed. And everybody was like, yeah, instead of fighting. Right. I had to do it, yeah, she was right, you know what I'm saying? It's only right to get credit that you was right, you know?
But like in
Me and Buffet, I think I always think that you, about you, but you was hopefully, it was in my shoe to my, and that's why everybody has something to say, and it's none of their business, and me, I don't have to, look, I don't stutter with what I say, I don't hide what I say, straight up, I'm a straight forward person. You're talking, why you don't answer, and you're saying something.
Because I think.
There's so much to
Like,
say.
you would think, 'cause
I'm feeling any of them right now, because they like,
I just
But
think.
would you be willing to pay higher taxes for free education?
for free healthcare.
Or free, yeah, I would be. So you don't think like the majority will?
And I like to be home. And then I'm
A
wrong.
lot of people will?
I would like to be home. Let me change that.
Yeah.
That is right.
Jacksonville, you don't get
What you mean?
the same increase.
So much. Last year we got a kitchen, a whole kitchen, an
Yeah,
iPod,
Oh, boy.
which is two. Why should we hold that stuff at home?
no, that's not, that's
It's
not.
hard, but she really, yeah, and her mother agreed it. I'm like, really? She's two. I said, she couldn't even read.
No, that's not true, don't do that. So my daughter,
She's two.
my daughter was carrying a BlackBerry when she was, and she was born
It's funny
07.
because you always use like watch like videos on YouTube 10 years and she figured out how she ignores it. And people call me, she tries to decline.
Yeah.
I have one at home.
Yeah.
My other one.
Yeah, but she had it.
So she really pregnant.
You have a kid, yeah?
No, when I have one, they're getting those little flip phones.
So that's
No, you know what it
better.
is?
She has an iPad that don't
No,
have
you
no
know
cell
what
phone
it is?
service.
I did because since my daughter was young, she had BlackBerry.
It's like a regular.
And then she had
I
iPhone, from iPhone 4 to 4C to.
I was in seventh grade when I got my first phone, and that's only.
No, you know the reason why I gave it to her? It's because she's smart.
In 8th grade.
The older.
No, for real? My kids don't have their phone
Seven.
way before 8th grade. My son was born in 93, he had a phone in 98.
But they don't.
In 90.
Right?
Oh,
You know my friend did one time, she was so desperate to get a new phone that we used to go to McDonald's every Wednesday because it was like a half a day. What is that? Just so she could get a new phone.
my son, my
You know what I
kids was good
think
with
that
phones. But they want to walk to school, you know, and I had to give them a phone because I was at work. My father was sanitation, and for him to go to 3rd grade, I had to give him a phone. Because that was like in
Picked up and
98.
dropped off, so we didn't
Yeah,
really
like I
need
only
a
needed
phone.
one.
My son used to work like a couple of
I had a babysitter, and I would pay her to watch him, but I would always, like, call, even made it to school, or him call me. So, I had to.
And then they had those little show signs that were for kids that didn't, they didn't have like a screen or texting on it, it only had like 3 buttons. And it was like just to call.
Mommy, daddy, and emergency. Mommy and dad. No, it was 3 of them. And emergency,
It wasn't like a
that's
cell phone for them to actually use.
it. Yeah, that
Or
was
like
cute.
you're good
They should have, they should have, but in 98 they had that.
That's right. It
was cost more than a phone.
like she's talking.
Monica found that.
And then she couldn't see why she wanted the sand. I bought the sand, and she said, no, I didn't want it. Got it look, got it tender, got it tender. Every seed with my daughter having home. She got every fish price and everything. They had, she had a college house where you could have a nice,
That's your word. That's your word.
kicked out of school.
That's your
word.
Try one, see if it, and then if you ever need to reset it,
And break
you
it.
could press this little button here with a pen and it resets the whole thing.
I teach them.
Oh,
You know, those honest, I'm the one that's
And finally go to the, you ain't calling for the place, you know that. You go back in the house.
Oh, no, I have them on March.
A girl is
I
the
was
best
there,
thing I have
they
for
could go, but I'm controlling.
to help.
I was like, hurry up, or you're gonna be on YouTube.
That's one thing.
Oh my God.
No, I'm just saying, if you can try a girl first.
Who's that request?
Yeah, girls go. Yeah.
I go to the girl and she's like, I don't wanna go.
Yeah. No, girls is like that. Boys is staying in high school, they grow.
That's not true.
For real, my son, I'm missing to their friends, I'm not doing it. She love you though. You said, oh, go away. Make that good teacher.
All right, continue. There's really just a couple things we're going to do between now and the end of class. One of them is a bit complicated, so we'll spend some time on that, but it's just really one more concept. But before we get to that, we'll revisit this point of margin of error. Remember I said that this whole thing that we add and subtract from the point estimate is our margin of error. So we'll just become familiar with that term. The other thing we'll talk about tonight is the fact that this population standard deviation being given to us is unrealistic. Because remember how we calculate population standard deviation is we calculate the difference on average from the mean of each of these data points. So if we don't have the mean, then we wouldn't be able to figure out what the population standard deviation is. So there's no reason we would have this. So we'll learn what to do when we don't. So margin of error, standard of error. So this whole thing is our confidence interval. Our sample mean plus or minus z-value times the standard error is going to give us that bracketed 90% confident, 80% confident, whatever the case may be. This part, the standard error, we are familiar with. And recall the standard error, the long term for that is the standard deviation of the sampling distribution of the sample mean. The whole thing, if we multiply that by the z-value, is going to give us something we'll call the margin of error. The margin of error is the amount we add and subtract to and from the sample mean. The margin of error is the maximum error, the maximum difference we might expect between our sample mean and the true population mean. Estimates of the true population mean measures the maximum difference we would expect between the sample mean and the population mean at a given level of confidence. It's the amount we add and subtract to the point estimate to get our confidence interval. So, margin of error. The next thing we'll do is if this population standard deviation is unknown, we have to do a couple of things. So again, standard deviation is the average distance from the mean of each of the data points. So if we're in a town where everyone makes a wildly different amount of income, that's going to have a large standard deviation. If we're in a town where everyone makes pretty much the same income, we're going to have a small standard deviation. So we calculate that based on the mean. And again, if we don't have the mean, we have no idea what the population standard deviation would be. So we do two things. One, we calculate our own standard deviation, which we'll call the sample standard deviation. And there's just a slightly different way we calculated that. If you look back to class 1, I'll have the formula up here in the next slide or two, but it's just a slightly different way we calculate it. The second thing we do is we use a different table. Instead of using the Z table, we'll use the T table. And the T table will give us a slightly wider interval. So instead of 1.96 to be 95% confident, the T table may take us to 2.1. It'll give us a wider interval to account for that lack of precision, so we can still be the same level of confidence. So when the population standard deviation is unknown, we will estimate population standard deviation with the sample standard deviation. Little s is the symbol we use for that. We will use the t-distribution. We will learn to read the t-table, and we will construct confidence intervals with the t-distribution. So the t-distribution is just a shorter, fatter version of the z-distribution. So the z-distribution is the tall, skinny one. T-distribution is the short, fat one. So if we want 95% of the data on the tall, skinny one, the z-distribution, we only have to go out to, say, here. But on the t-distribution, we have to go further out. So instead of 1.96, I said it's going to be like 2.1, something like that. So this is just the same thing we've talked about. When the population standard deviation is unknown, like it always is, we calculate our own sample standard deviation, and then we use the t-table. It turns out the t-distribution is a family of distributions based on something called degrees of freedom. Now, degrees of freedom, it's a very complicated term, and I won't trouble you with the details of that. We'll talk a little bit about it later, but for now, I just want you to think of degrees of freedom as roughly the sample size. So, the bigger sample you have, the more degrees of freedom you have. So if we have 15 degrees of freedom, which is roughly a sample size of 15, I'll tell you about the nuance in a minute, versus a sample with 5 degrees of freedom, which is roughly a sample size of 5. This 5 degrees of freedom is going to be shorter and fatter. We're going to have to go further out than we are with the t-distribution, which is taller and skinnier. So let's actually turn to the t-table right now and think about how we read that. There's one in the back of your textbook. I think it's a couple pages past the Z table. It's actually can be easier to read, I think. There's less chance of making a mistake in reading the T table. All right. Yeah, T distribution, page 570. Alright, so t-distribution is read with degrees of freedom on the left-hand column. You look down how many degrees of freedom in your sample, and then you will look area and the right tail in the columns as you go to the right. So, for example, if we want to be 95% confident, it means we're going to get it right, get it wrong 5% of the time. 2.5% up here, 2.5% up here, down here. Okay. And so if we're 95% confident, the area in the right tail is 2.5%. So, suppose you have 5 degrees of freedom, this short, fat distribution, and you have 2.5% in the right tail. You look at 5 degrees of freedom on the left-hand side, and scroll over to 0.025, 2.571. Okay, so you would need to go 2.571 standard errors plus or minus. What if you had 15 degrees of freedom? .131. Okay. Did everyone see that on the table they're looking at?
So we never go over, we try to stay under.
I'm not sure.
Okay, so it's either 2.131.
No. I think you must be looking at the wrong thing.
Okay.
Yeah, so you go, do you have the book?
Oh, the right tail is 2.5.
Yeah.
Percentage.
I bring my chart, I didn't put it in the book, cause I got the loose one, they don't have it on the book.
So we're looking at the tail of the 2.5?
I'm gonna bring it.
And it's gonna be this here, this one, .025.
No, I got it.
Not all T-tables are exactly
Yeah,
the
that's
same.
Yeah, and that's what I'm trying to look online,
And
but
then you
Yeah.
got
I'll bring it
15,
with
and
me
then you
the
get,
next
Alright,
time.
or maybe for now, make friends with someone who has a textbook. So you can just look on. You got it. There, you're good. You have a textbook?
Book is right.
Book is right there. You're good, you've seen it? Seen it? Seen it? Seen it? Read it, read it. 570? Page 570.
No, I took half of the book out.
Or turn around, look at it.
Is this it?
No.
Look,
Look on the page. Look on the page. Or you can come back. So if you're 5 degrees of freedom, area in the right tail is going to be 2.5.
and I'll bring
Alright, how about degrees of freedom equal to 30? What's the t-value in that case?
2.042.
How much?
2.042.
Alright, degrees of freedom, 120.
1.980.
198, okay. Degrees of freedom, 400.
I don't got that far.
Oh, could you put like 300?
I'm hurting.
1.96, yes. Alright, so anything above 120, use 1.96. This 1.96, does this look familiar?
Yes.
Sir.
This is what you would use if you were using the Z table. So as we get more degrees of freedom, bigger sample size, we can use a smaller number, ultimately to exactly the same thing we would use on the T table. Okay, So as the degrees of freedom increases, the distribution looks a lot like the z-table. Okay, quick reminder on how, alright, so we're doing two things. One, we're calculating our own sample standard deviation, and two, we're reading the t-table. So we've had a little taste of how to read the t-table. Let's remind us, how do we calculate our sample standard deviation? If you cast your mind back to class 1, you recall when we're calculating the sample standard deviation, we have this n minus 1 in the denominator, and that's going to make this bigger. So average distance, we square it, sum it all up, take the square root of it. Before we do that, we divide by n minus 1 instead of n. And so this sample standard deviation is going to be a little bit bigger as a result. Alright, now this n minus 1 will be specifically what we'll call our degrees of freedom. Remember I said think of it roughly as sample size, but it's actually n minus 1. So if we have a sample of 30, what is our degrees of freedom?
29.
29, exactly. 29. We have a sample size of 50, degrees of freedom is 49. Okay, so for degrees of freedom, I told you think of it roughly as sample size, but think of it specifically, the actual definition is sample size minus 1. And that's all we really need to talk about for now. When we get to regression analysis, I'll tell you a little bit more about the mathematical definition of degrees of freedom, but this is all we need for now. Alright, so this is how we're going to construct our confidence interval. It should look familiar. We're going to collect some data. We're going to get a sample mean from that data. Now we still want to know the true population mean, but we do not know the population standard deviation, so we're going to have to change this around just a little bit. Instead of using the z-table, we'll use the t-table to account for the lack of precision. And this standard error term is now going to include our sample standard deviation instead of the population standard deviation. Everything else works the same way. Yes, Ted?
So in other words, instead of us being given the standard deviation previously, we're just using our data to calculate the sample.
Exactly, exactly. So if you had all your data, you'd put it in Excel, and you would, use the formula for sample standard deviation. If you liked punishment, you would calculate it out yourself. So let's try a couple of practice problems. Let's try page 257, number 36.
Yeah, that's crazy. That 95 is TT. I don't know what they mean. Let me ask you a question. Now, on TT, how can you determine which, for the 95%, do we do it the same way we did it?
Yeah, so 95%, how much area is gonna be in each tail?
So it'll be 2.5, 2.5.
Yeah. You're gonna get around 5% of the time, 2.5% down here, 2.5% up here.
And so we end up with 2.5%?
Yeah, because
So we have
it's
to use TT.
right tail area.
Right.
Yeah, that'll remind you.
Got you. So if we do 2.5, so will we be in this area right here?
Yeah, so 2.5% is 0.025.
Right.
That's the same thing. And that's 1%, that's 0.5%, that's 10%. So you're gonna look down here, how many degrees of freedom is 20 minus 1, which is 19, right?
Right. 'Cause
So we're gonna look down to here, right?
Got you.
On the right hand above it, right, if I could understand the question when I'm writing it and I'm doing it, that's why I'm getting the answers to the. And read it, right, at the same time. What's the only way I'm getting to, and why the numbers go right. I really feel like